This is the switch we use in the now. And now the VIPNet backbone. First, you have a link. Now you have a border or a data center where you receive this link and administrate this link. But for an internet service provider, you need to go with this link to the home of your clients. And for that, you need to do a backbone. We have a backbone with a lot of different technologies. One is radio. We have a backbone radio. What's good in backbone radio? It has a good transport capacity, very accessible prices, cheaper than fiber. It has OSPF routing in these radios of MikroTik, and it is quick to install. To put a link of 500 meters, 2 kilometers, 10 kilometers, it was easy. One point, another point, 2 radios, in a few minutes you can do it. And you can go to big distances using these equipments. It was the equipment we use, the sleeve and the radio. This radio from MikroTik can give you up to 1.3 gigabits per second. It was a lot of bands. Depending on how many users, customers you have, it was much more than the necessary. This is an example in Gambia, a country in Africa, where we do a link from 75 kilometers and near to 1 gigabit of band with less than $800. This is the designed band. The equipment was the metal, MikroTik. This is the antenna where we see some slides ago. The distance, 75 kilometers, reliable, and 7 meters was the first Fresnel zone. You need one tower with only 7 meters, not a giant tower to put these antennas. This is the design of the link. It was near to the Gambia's river, and with an equipment extremely cheaper. When you have internet service provider, it was very important, go to far and far and far to take more and more clients. And radio was excellent choice to use. One radio point-to-point for Ginadis, for an example, it was 14 kilometers with near to 1 gigabit of bandwidth, or with 45 kilometers with 300 meters. Everybody talks about fiber. Yes, fiber was the future. But it wasn't interesting. Forget the radio. We start with the radios. We start with wireless internet service provider. We goes to the fiber, yes, but we understand fiber was the best, but we have a big space to work with wireless too. And these radios we are looking was from backbone of the network. And this equipment only $175 to do a link of 45 kilometers. It was nothing, it was cheaper than this. And this equipment used a licensed band, 6 gigahertz of band. No problems with interference. Another equipment of MikroTik used in backbone, nearly to $200 and 2 gigabytes. VIPNet has backbone in wireless and a backbone in fiber. In fiber, we do our backbone. Fiber is the future, has no escape. But fiber, no interference, high transport capacity, more than 1 gigabit, only fiber to work very well. but high costs of deployment. It wasn't cheaper fiber. And the maintenance was the cost of maintenance was high because you need a machine to work with fiber, to splitters, and lots of other equipments. In backbone, we use only point-to-point connections. And for this SFP, for an example, gives us 8 kilometers of range. You can have a point of presence in one point, only one fiber, and 8 kilometers more, you have another point of your network. Or with this one here, with 10 gigabytes of network. You have a backbone with 10 gigabytes. With this other, we use these two kinds of SCFP. In the backbone, we use the fiber switch to receive. Each POP has a fiber switch connected to one other POP or to the border. This switch has 16 SCFP. You can put 16 different POPs connected with this one here. And your network grows a lot. This is an example. You have two switches, one fiber connecting two switches, two SCFPs, and with only two SFPs, two switches and a fiber, not a lot of money, you can go 8 kilometers with 1.25 gigabytes. The fiber cable has a lot of fibers, not only one. We are using only one fiber of the cable in this backbone. But the network grows, more clients, more demand, more band. What we do? We are using only one fiber. With another fiber and another pair of SFPs, you can go to 2.5 gigabytes. Extremely simple, few minutes to install and to grow the network. With one cable like this, with 24 fibers, you can go to 30 gigabytes of backbone transport. And if you use this one, each one gives you 10 gigabytes of bandwidth. With 24, more than the necessary now. The VIPNet backbone was basically radius point-to-point and fiber point-to-point using SFP and switches. We have the network of access, the access network. The access network, we have 5 different scenarios. We have residential wireless client. We have Ethernet resident client. We have resident fiber client. We have corporate fiber client and corporate radio client. For each scenario, we use different equipments, different technologies to give the service who was necessary. In the first scenarios, where we have the residential wireless client, we have a customer. In this customer houses or company, we install an antenna, a CPE, where we have a PPOE client and NV2. It was very important to stability of their network, use only one equipment or all equipment compatible with the same technology. The best one now is NV2. And we have an AP, an access point, in the tower, in a POP. This AP was a PPOE server, QoS, routing OSPF, firewall, QoE, and NV2. This is the scenario of wireless connection residential. This AP was connected to the backbone, and the backbone connected to internet. This is the access network for clients wireless. This is the equipment, more interesting, more well used. an AP for microchip. You have